Hi, my name is Tanner McLean-Poll, and this is the myth of the rising fastball. So, if anyone who's listening doesn't know how baseball works, the fastball is the standard way to throw a baseball. It's the easiest way to learn, and it's the least damaging for a kid's arm who's still growing and developing. So, this way of throwing goes back way into the 1800s, so people for a very long time have been trying to figure out how to throw the most effective fastball. This progression over time has led to the belief that one of, if not the most effective type of fastball would be one that can defy gravity and move upwards. This is in stark contrast to the curveball, which is a pitch that has front spin on it rather than back spin like the fastball, which causes the ball to curve downwards with gravity. From a technical baseball perspective, this would be a far easier pitch to hit, as going with gravity in order to hit a ball is much easier than going against gravity to go up and hit the ball. Because this myth has been around for so long without any visual confirmation that this myth has been confirmed, there were a few assumptions that were made in order to give the greatest chance for the baseball to be confirmed to be rising. The first out of these assumptions is that the ball is assumed to only have backspin with no side spin. To get a little bit more technical, this means that the pitch being thrown is called a four-seam fastball, which traditionally has a lot less horizontal movement than a different type of fastball, such as a two-seam fastball, a cut fastball, or a sinker. Just as proof that this is a realistic assumption to make, there is a pitcher in Major League Baseball on the Tampa Bay Rays named Oliver Drake, and what makes him special is his arm angle that he throws at is completely straight up and down, which is very rare in baseball, as uh, a lower arm angle generally means more horizontal movement, which in baseball is generally better and you'll get better results out of it. However, this guy has had lots of success with his more vertical throwing motion. The next assumption to be made is that the buoyancy force was assumed to be negligible, and this is mainly because the ball is traveling through air, which generally has a very low density, and in calculations while working on this, it was found to have almost no effect on the final solution. The final assumption for this myth has to do with the lift coefficient, as this was taken from a reputable source. This was done because, based on research while looking into this myth, I discovered that the lift coefficient was found by using experimental analysis, and it was using equipment that I simply don't have access to, and therefore could not get an accurate lift coefficient. Now, the reason that this myth is even possible is due to the phenomenon known as the Magnus effect. This effect takes place on any ball that is spinning. The way it works is because as a ball is moving through the air and has any amount of spin on it, there will be one side of the ball that will have more velocity relative to the air than the opposite side of the ball. When taking these velocity values and using them in the Bernoulli equation, it's clear to see that there will be a pressure differential as the density is the same, the gravitational acceleration is the same, and the heights are the same, meaning the velocity is the only thing affecting the pressure from P1 to P2. In order to find a value for the lift force, the Kutta-Joukowski lift theorem for a cylinder was used. By breaking the variables of this equation down into their base units, we are able to get a formula for the lift force of a cylinder. However, because a baseball is not a cylinder, there needs to be some integrations that have to do with the radius and the angles in order to account for that. These integrations help to model the baseball as a whole bunch of really small cylinders in order to use this theorem with the shape of the ball. As stated previously, the lift coefficient was taken from a reputable source and it was found to be 0.15 for a baseball. This is because of the material that the baseball is made out of, and also the seams that stick out of the ball have a large effect on it too. Now that the equation for the lift force of the baseball has been found, data can now be used and plugged into this equation in order to analyze this myth. The data that I've decided to use comes straight from the Major League Baseball website. They have a feature on their website called Baseball Savant, and this is a database that has been tracking and recording data from every single pitch in every single game ever since 2008. The data that was on here was relatively primitive until 2015 when they introduced StatCast, which was a tracking technology that could way more accurately depict the pitches that were being thrown and the balls that were being hit. Even though pitch velocity has been tracked ever since 2008, the spin rate on a baseball has been one of the newer features that they've added with the StatCast era, and so the data only goes back to 2015. With this in mind, I took the 150 highest spin rate fastballs thrown since 2015, as well as the 150 fastest fastballs thrown since 2015. The high spin rate data ranged from 307 RPM to 3,660 RPM. Meanwhile, the fastest fastball data ranged from 102.9 miles an hour to 105.7 miles an hour. All 300 of these pitches were plotted with pitch velocity versus spin rate to give a visual representation of what these pitches looked like on a graph. Following this, a curve was constructed by setting the force of gravity equal to the lift force, and this was able to give us a representation of where these values needed to be in order to be considered a true rising fastball. In the end, when putting these 300 data points on the same graph as the curve of the rising fastball, none of the points were even particularly close, proving that there is no pitcher that is alive today that can throw a rising fastball. To test this theory further, I plotted the highest velocity point along with the highest spin rate point together to see if the combination of the fastest pitch with the highest spin rate would create a rising fastball. Although this combination leads to the closest to a rising fastball, it still doesn't cross that line, meaning the ball does not rise. This means that as of right now, the myth of the rising fastball has been busted. When looking back into historical players, it is still possible for this myth to be confirmed. However, there was a documentary put out in 2015 called Fastball. And what this documentary did is it looked throughout history at who threw the true hardest ball in history. This led to taking a look at September 7th, 1974, where a pitcher named Nolan Ryan threw a pitch that was confirmed to be at 100.8 miles an hour. This speed is obviously slower than the confirmed record of 105.7 miles an hour. But the reason that this was taken a look at is that speed was clocked 10 feet in front of home plate. This means that the ball was traveling at 100.8 miles an hour after traveling almost 50 feet in the air, whereas the current record of 105.7 miles an hour was taken at release point. Within the documentary, they calculate that this 100.8 miles an hour is the equivalent of 108.5 miles an hour at release point, which is obviously faster than 105.7. So when taking this new unofficial record of 108.5 miles an hour and plotting that with the current spin rate record of 3,660 RPM and plotting that on the rising fastball curve, we still don't get a data point that crosses the threshold at which the ball would be considered rising. This is because at 3,660 RPM, a ball would need to travel at 116 miles an hour in order for the lift force to become equal to the gravitational force. Since it's also been theorized that the absolute maximum speed that a human can throw a baseball is at around 110 miles an hour, this myth will never be confirmed. This maximum is 110 miles an hour, not because a human can't possibly throw faster than that, but rather the ulnar collateral ligament, or UCL, can't handle more force than what is produced at that speed. Now, even though spin rate technically is a variable that can be adjusted to get a ball over the curve, it is such a new thing in baseball since it's only been tracked ever since 2015 that not enough is known about it to know if there's legitimately a way to significantly increase spin rate in order to make a rising fastball. With that being said, if there are advances in baseball technology and techniques that will increase spin rate, technically that is the only way that this myth will not be busted. In conclusion, the myth that was tested is, can a human throw a rising fastball? And the answer to that question is no, a human cannot. It is technically theoretically possible if we find a way to increase the spin rate on a baseball or create robotic UCLs, but at this time, the myth is busted. and there is no such thing as a rising fastball. Thank you for taking the time to listen.